Hi, it's Tom, and this is the first in a series of videos in which we'll talk about comparisons and conversions in C Sharp. If you're a student in my class, you'll be able to download this starter file. So one of the first things that we'll do in this video is give you a quick orientation to what you can find in the file. First, there's program.cs, which is where our program class and main method are. You can change the author tag to your name and update the date if necessary. Right now. And basically what's in here, main is more or less already coded for you. I decided that because we're going to be demonstrating a lot of different things, it might be easier just to show a menu of the various different things that we're going to test as the videos progress, and then call a separate method for each sort of each thing that we're talking about. Okay, so basically in main, I display this menu. There are 7 parts. It's kind of intimidating, but to be honest, I've tried to break down the videos into smaller chunks, so none of them are especially challenging. Any rate, we display this menu. The user, presumably you, will enter in your choice, okay, which is stored as a string, by the way. I go through this switch. I could have used an if-else chain, and depending on what you entered in, I'm just calling one of these methods. I'm actually departing from the style guide slightly here, and I'm allowing an underscore in my method name just because it makes the method a lot clearer what it is. So any rate, so yeah, there's the 7 parts and there's 7 corresponding methods. And if you entered in something that wasn't 1 through 7, it sets the menu choice to retry because I'm continuing a loop while the menu choice is retry. Okay, that just limits it to the 1 to 7 there. There's an exception block where I show what the exception is, and then there's a finally block that just pauses the program. So that's basically the main method, very straightforward. You don't really need to do much or anything really to it. So I'm just going to shrink it up. The rest, excuse me, rest of the program class is again all the individual methods. So I'll just look at one of them here. Part 1 value reference. So you can see what I've got, a little summary tag at the top and the setup for the method so that it actually runs. And then there's some comments inside it, but we're going to be adding the code as we make the modifications to the various classes and structures and interfaces and stuff we need to do, and filling this in. So this is where we'll actually code what we're testing for part 1, and then of course it goes on with the other different parts. In part 1, by the way, what we're going to be demonstrating, something we already know about, is the idea that objects in C# are reference types and structures are value types. So it's just a good place to start to review that. We'll write a little function here that where I create an object, or actually 2 objects, modify one and display both of them to see if modifying one affected the other, and do the same kind of thing with a structure, which is a value type. Let's have a look at the main class object class that we're going to use in this series of videos, which is Cartesian Point. So in Cartesian Point.cs, first off, Cartesian Point is set up with all the other stuff we've had in previous videos. So if I expand the previous tutorials region, I'm going to see the X and the Y properties. I'm going to see constructor, a default constructor. I'm going to see set point to string. I have the minus operator, which we added before. It's the distance between 2 points. We added we added an iterator. We had get enumerator to support the interface. We had some shallow, added a method called shallow clone, as well as a clone method to support the interface iClonable. So we went through all of this in previous tutorials, so we don't need to go through it again. I'm just going to shrink up that region. And I'm going to try to shrink up that region. There we go. And then I've also got a region called this tutorial, where you're going to see we're going to be adding some stuff in. We're going to be adding the equality operators, as well as some other methods that relate to equality, and relational operators. Will also overload, so there's some comments for that. That's a big chunk of it, but a lot of these are really small little ones. We're going to talk about the iComparable interface, and as a result, what we need to add to support that, which is called a method called compare_to. And then finally, we're going to overload a conversion operator that's going to convert a Cartesian point into something I'm calling a simple point. Okay, so let's have a look at the simple point, see what that is. This is already defined for you. But what simple point is, it's a basic structure, okay? And there's only two things in it, two public properties. They're both automatic properties, one for x, an x value, and one for a y value. Okay, so what this structure does is it just allows an x and a y to be stored, retrieved, set, etc. Now what I've done here is you'll notice that the simple point structure supports an interface called iCoordinate, which is an interface that I created. I'm going to just quickly look at iCoordinate right now. Again, it's coded for you. You don't have to modify this one, but this is an interface that specifies that whatever supports iCoordinate has to have a public integer property called x and a public integer property called y. So simple point in essence is the bare minimum we could do to support iCoordinate. Now the Cartesian point class that we were dealing with before also has public properties for x and y. So in fact, what's already coded for you is the fact that Cartesian point also supports the iCoordinate interface. So we've got a class where we can instantiate objects and a structure where we can instantiate, create instances of, or data structures called simple point, both which support this class. That allows us to do some things with both of those different types of items, which is going to be handy in this particular tutorial. All right. There is one more class in the project. It's called Cartesian Point Alternate Compare, and we'll deal with that in a later video. Okay, but it's for making comparisons between Cartesian points. But as I said, we'll deal with that later. So for now, what we're going to do is we're going to go back to the program class, and we're going to actually go through the part 1 value reference method here to just demonstrate the difference between, Cartesian points and simple points are kind of similar, but since one's a class and the other is a structure, they will behave a little bit differently. So we'll try that out. So I'm just going to create a very, just an example Cartesian point object. I'm going to call it original object. I'm just going to use the default constructor. It'll end up being 0, 0. All right, let's create another Cartesian object, and it says based off the original object. So what I'm going to do for this one is I'm going to call it another object, and I'm going to make it equal to the original object. And we know from previous experience here that we don't actually have two instances in this case. We have two names that both refer to the same Cartesian point in memory. Okay, so when I go through and set the x and y values to 99 for the using the identifier another object, what's going to happen is that we'll actually set the x and the y for both of these objects. And just to prove that, what we'll do is we will display some information for both of those objects. All right, just scroll down a little bit. You'll notice that there is another method called display coordinate info. You can expand that out if you like. It's already coded for you. What the display coordinate info does is it takes as a parameter anything that supports the iCoordinate interface. So it's a iCoordinate interface variable. So I could actually send this either Cartesian points or simple points at this particular juncture. So what it does is internally it just shows some information. One, the actual type, which uses the .getType method that is inherited from object, I believe, and the x value and the y value. So as long as what I send to this is in fact supporting the iCoordinate interface, this should display what I want. So I'm going to use this method to actually display the two objects. All right, so I just have a little console right line. The objects are reference type, just a little reminder in my output. I'm going to shrink this a little bit so you can see the end of the line there. So I'm going to go ahead and run this and just see what it looks like so far. Okay, so in my menu, the only one that's got anything going right now is 1, so I'll choose 1. And it says objects are reference types. Okay, and we can see the original Cartesian point was, which was 0, 0. After I modified the second one, they're both 99, 99. Okay, so that just verifies what we already knew, the idea that the objects are actually reference types. Let's go through the same steps for creating a simple point structure. Okay, so we'll create a new simple point structure. You know, there is no actual constructor for it, but that's fine. I'm going to call it original struct. And then I'm going to create another one. I'll call it another struct based on the original one. Okay, so the code is very similar to above. Okay, but what's different, of course, is that because structures are value types, we actually do have 2 separate structures now. Okay, the second one has just essentially been initialized to original struct. So we'll set the x and y values. I don't have a set point method like I do in the Cartesian point class. I just have to go through the properties. I'll set each one to 99 just to be consistent, arbitrary but consistent, and then display the actual structures. I'll use the same display coordinate info method. Excuse me. All right, let's run that again. Okay, so again, I want the first demo. And now we can see, you know, the 2 Cartesian points are the same because it's the same Cartesian point, whereas the simple points, because they're value types, the original one was not modified when I modified the second one. So again, just verifying what we already know. So in this video, we got a quick orientation to the starter project and what's in there, and we verified that objects are in fact are reference types and structures are value types, and what that actually means. In the next video, what we're going to do is we're going to talk a little bit about what boxing means, and of course unboxing as well. It's closely related to the idea of value versus reference types. Thank you very much.